Okay, so today, inshallah, we are going to pick up from where we left off. That is, we're going to resume differentiation. And we're going to do some important concepts of differentiation. We're going to learn how to differentiate composite functions, okay? And we're going to learn how to differentiate. We're going to learn about equation of tangent and equation of normal. If time allows, we're going to do equation of tangent and equation of normal. Other than, composite functions, learning how to differentiate composite functions is what we're going to do anyway. So I have a question. When finding range of a function, we could either substitute the domain in the place of x or do the turning points. When finding the range of a function, we could either substitute the domain. Okay, Ikra, there's no yes or no answer to that question. If you remember, we did a whole we did a lot of trial and error for questions like these. How to find out the range of function. Okay, it depends. If it's a one-to-one function, then you can substitute the x values. If it's not a one-to-one function, if it's a many-to-one function, then you need to first find out the minimum and the maximum turning point value, depending on the nature of the function, and then decide the range. Okay, so why don't we learn practical concepts like y minus 1x? I said, okay, about that, if you remember, I said that we are going to learn that, but it's not something that we're going to be tested on. So it's not top priority. Okay, it's something that we're going to learn. Like, for example, it's always a good idea to see where the formulas come from, but not top priority. Okay, so which is why we're going to put this also on the back burner. If time allows, we'll do it. If it doesn't, it's okay. We're not losing out on anything. All right. So it's not something that will impact the understanding of the concept. Okay, if it was something that would have impacted the understanding of the concept, I would have surely done it in the beginning. But because it doesn't, that's why it's not top priority. So when are we going to complete whole differentiation? Coming week. Okay, coming week. Inshallah, by mid-January, we would have completed differentiation, and then another 2 weeks for integration. Okay. Anyway, so let's start. Let's not waste any more time. Let's start immediately. And let's do a quick recap of all the concepts that we have learned before we move on. So who can tell me the primary objective of differentiation? Like, what do we differentiate for? What's the primary objective? To get the gradient. Yes, to find gradient. Okay, the reason why we differentiate is to find gradient. Now, that gradient could mean a lot of things. Okay, and that gradient function can help us do a lot of things. That gradient function can help us find the minimum value, the maximum value. How we're going to do that, that's something we'll discuss later. Okay, that gradient can help us find out speed, which is what we're going to learn in kinematics, acceleration, a whole bunch of things. Okay. Now, what is the general rule of differentiating a power function? If let's say you have ax to the power n, can anyone quickly explain to me what the differential will look like? What dy by dx is going to look like? Multiply and n minus 1. Yes, multiply the power by the coefficient of x and take 1 away from the power. All right, long story short, that's what it is. Okay. Then what if x is in the denominator? What do we do then? What if you want to differentiate and x is in the denominator? We have to bring it in the numerator. That's correct. And when we bring it in the numerator, what happens? What rule do we follow? The power becomes negative. Okay, so remember, even though we're doing differentiation, we can still use rules of indices if we have to, depending on the question. Okay, so next, like I said, we are going to learn how to differentiate composite functions. Okay, now don't confuse this composite function with what we did in functions. Okay, I'll tell you what a composite function looks like. And sometimes you will see this concept written as chain rule. Okay, more about that later, as in why we call it chain rule. That will come later. So let me write down the date. It's the 9th of January. Now let's say that you have something like this. Y is equals to, let's say you have y is equals to x plus 2 the whole thing cubed. Okay, and you're asked to differentiate it. Now, one very convenient, not convenient, but one very obvious way of differentiating this would be that we first expand x plus 2, the whole thing cubed, and considering the fact that we know binomial, we can do that. And then we differentiate it, but that is not very, that's going to be very time consuming. So instead, there is a shortcut, okay? And the shortcut is, again, pay close attention to what the shortcut is. And whatever questions you have, hold on to them. Let me do at least 3 examples, then you can ask, okay? The way that we're going to differentiate a function like this is as follows. So first thing we do is we differentiate the power. So we take the power, we multiply it by the entire function. Okay, so the entire function is being has 1 outside of it. So 3 times 1 is 3. Okay. Then you take 1 away from the power. So 3 minus 1 is 2. Okay, and then you multiply it by the differential of the expression that's inside the bracket. That means differential of x plus 2. And what would you get if you differentiate x plus 2? You would simply get 1. And then you write your final answer nicely, which means dy by dx is equals to 3x plus 2, the whole thing square. Now, I'm pretty sure 80 to 90% of you would be absolutely clueless right now as to what I've done. That's okay. Let me do at least 2 more examples, then write the general rule, and then you'll have some understanding of how this works. So here's another example. Pay close attention. Y is equals to 3x plus 5, the whole thing square. Okay. How exactly are we going to differentiate this? Let's see. Dy by dx will be equal to 2 times 3, which is 6, x plus 5, take 1 away from the power, that's 1. So what we have done right now is we have differentiated the power, okay? Then we multiply by the differential of the expression that's inside the bracket. So x plus 5, what happens when you differentiate x plus 5? What do you get? You just get 1, okay? Then if you write your final answer, what is that going to look like? That's going to look like 6, bracket open, x plus 5. If you want, you can write the power 1. If you don't write it, that's perfectly all right because it makes no difference at all. Let's do another example. Let's say you have something like this. Y is equals to 4 into 3x minus 1, the whole thing power 4. So first step, you differentiate the power. How? By multiplying the power with the entire function. So 4 times 4, that's 16 into 3x minus 1. What happens when you take 1 away from the power? 4 minus 1 is 3. And then what do you multiply it with? You multiply it by the differential of the expression that's inside the bracket. Inside the bracket, you have 3x minus 1. What happens when you differentiate 3x minus 1? You get just 3. And then you simplify it. 16 times 3, that's 48. Into 3x minus 1, the whole thing cubed, and that is your dy by dx. Okay. Now let me write down the general rule here, and then if you guys have any questions, feel free to ask. And don't worry about the why part of this, as in why we do what we do. We can look into that also. Not right now, but we can look into that later on. So if let's say you have a function that looks like this. A bracket open, px plus q, the whole thing to the power n. What would be, what would dy by dx look like? So dy by dx would be n times a multiplied by px plus q to the power n minus 1 multiplied by the differential of px plus q, which in this case is going to be p. So the final answer is going to be nap px plus q to the power n minus 1. I'll answer your question in just a minute. Let me get through this. There you go. How did I get 1 in the first and the second example? Are you talking about the power 1 or the one outside the bracket? Outside, okay. What do we multiply in the end? In the end, we multiplied by the differential of what we have inside the bracket. So what is the differential of x plus 5? The differential of x plus 5 is just 1. What happens when you differentiate x plus 5? Forget everything. Just tell me what happens when you differentiate x plus 5. 5, the differential of 5 will be 0, but what happens when you differentiate x? You get 1. So that's why we get 1. Okay, I'll explain this again. Instead of explaining it again, I would prefer that I do another example. Okay, I'd prefer another example rather than explaining it again. So let me write down another example, and then let's do that. This rule still works if x is in the second term. Yeah, of course. Doesn't matter whether x is in the first term, second term. That doesn't matter. Okay. So let's say we have another example. 3 bracket open 2x minus 1, the whole thing power 4. Walaikum salam, Shayan. Now let's differentiate it. Let's see what we get. Dy by dx is equals to 4 times 3. That's 12. 2x minus 1 as it is. We take 1 away from the power, so that's 3. Then what do we multiply it with? We multiplied by the differential of the expression that's inside the bracket. So what do we have inside the bracket? 2x minus 1. What happens when you differentiate it? You get 2. And then can we simplify it further? Yes, we can. So 24 into 2x minus 1, the whole thing cubed, is our final answer. Now, any questions? Okay, let me do another example. Okay. Ubaidullah, yes, that is also what chain rule is, and this is also called chain rule. Why we call this chain rule as well is something we're going to find out later on. Okay, this is also called chain rule, but we'll see why it's called chain rule in later on when we officially do chain rule. Okay. Acha, I'll do one more example, then I'll scroll up. You guys can copy all the examples and ask as many questions as you like. One last example. So y is equals to square root of 2x minus 1. So this doesn't look like all the functions that we have differentiated so far. What does that mean? That means we can't differentiate it? Or does this rule doesn't apply to this kind of function? What do you guys say?
We will, but we just write the square root as power half.
Yes. Okay, so what we're going to do is we're going to write it nicely. Or in other words, as I like to call it, we're going to make it differentiation ready. Okay, so that it's ready to be differentiated. At the moment, it's not, but when you write it like this, you can see that it's just waiting to be differentiated. Now, if you differentiate it, this is what it looks like. Half into 2x minus 1 to the power half minus 1, okay? And then we multiply it by the differential of the expression inside the bracket. So what happens when you differentiate 2x minus 1? You get just 2. Now here there is some simplification that we need to do. Okay, what is that? If you think about it, we can cross out this 2 with this 2 because half times 2 is just 1. So what we're left with is this. Dy by dx is equals to 2x minus 1 to the power negative half. Or, you know what else you can write this as? You can write this as 1 upon square root of 2x minus 1. Okay, can anyone explain what I've done from here to here? It's not that complicated.
We just took the fraction in the denominator.
Yep.
And put a square root rather than of this half power.
That is what I did. Okay, when you
That's
take the...
With the minus go with the 0.5.
What happens when you take the reciprocal?
Okay.
Get it?
Yes, sir. Perfect. Thank you.
You're welcome. All right. So, any other questions? If yes, feel free to ask and take a good look at it before you have any questions. Here's everything zoomed out. Okay, so I'm judging by the silence, no questions. Khair, if you do come across, if a question does come to mind later on, you can ask me later, not a problem. At the moment, I'd like us to solve a few questions so that we get a good grip on it. Now, let me tell you, I think I said this before as well, and I'll probably keep on saying it. Calculus is majority of the calculus that we're going to do. It is just 10 to 20% concept. The rest is all algebra. Okay, algebra and simplification and all that. So make sure that you guys are mentally prepared to solve questions like these. Okay, Don't rush into them. Don't make any silly errors. Check as you go along, and you'll be fine. Okay. Okay, we're not going to solve all these questions in case you're freaking out or something. We're only going to handpick and solve a few questions. Calculus itself is difficult. Okay, so the thing I've noticed about calculus is this: either people really like it or they don't like it at all. That's what I've noticed. If you ask me as a student, I loved it. I don't know how you guys feel about it. So I'll let you guys be the judge. Okay. And if you really like it, then, it doesn't matter to you how difficult it is because you're really into it. But if you don't like it at all, then, you'll probably give up at the first sign of trouble. I have seen people saying it's easy till high school, but in uni, yeah, of course. When you get to uni, you're doing a whole different level of calculus. Okay, like let me tell you something. We have a topic, differentiation. Okay, we have a topic in math that's called differentiation. Just like that, we have a topic in math that's called integration. When you get to university, because in university, if you're studying math at a higher level, you're specializing in it. Then you're not going to have a topic called differentiation. You're going to have a whole subject called differential equations. And just like that, you're going to have a whole subject called real analysis, complex analysis. So that is when things get really annoying. But right now, it should be smooth sailing so far. Okay, so I would like you guys to solve a couple of questions for me. Do part B, do part G, and do part E. Quickly. I'll give you guys not more than a minute. When you guys have the answer, do share it with me before you do the next part. I told my dad and Chachu I was struggling with differentiation in maths, and they were like, "Yeah, we were the same in college, so the struggle." Okay, the differentiation that we're doing right now. Let me tell you guys something. It shouldn't be that difficult for you. Maybe it is going to be difficult initially, but that's not how it should be throughout. Okay, you should always try and make sure that you at least learn the fundamentals. Okay, as in how to differentiate power functions, how to differentiate composite functions. That is something that you should really have a good grip on. Okay. All right. So, do we have the answer to part B? I can see that you guys have already shared the answer. It's going to be 16 into 2x plus 3 to the power of 7. That's correct. And then do we have the answer to part E? Hmm. 10 into 5x minus 2 to the power 7. Yeah, that is correct. 10 into 10. Yeah. 10 into 5x minus 2 to the power 7. Okay, what about part G? No, it's not 20. Don't forget the upon 4. Okay. (56 into 4 minus 7x to the power 3). Okay, let me just double check. 8 7s are 56. That's correct. 56 into 4 minus 7x to the power 3. Yeah, I can solve part E. Pay attention. So I would suggest that you first write it like this. 1 upon 4 into 5x minus 2 to the power 8. Okay, won't it be minus 56? Yeah, actually it will be minus 56. Thank you, Moment, for pointing that out. So this is what the function is. So what happens when you differentiate it? Here's what happens. 8 you multiply by 1 upon 4. So you can write it as 8 upon 4 for a minute into 5x minus 2 to the power 7. And then you multiply it by the differential of the power, which is 5. So simplify now. 4 ones are 4, 4 twos are 8. 2 into 5 is 10. So 10 into 5x minus 2, the whole thing to the power 7. So there you go. This is your answer. Yeah, I can do that. So this is what it looks like. 2 into 4 minus 7x to the power of 4. What happens when you differentiate it? This is what happens. 4 into 2 is 8. 8 into 4 minus 7x to the power of 3 multiplied by the differential of 4 minus 7x, which is going to be minus 7. So 8 into minus 7 gives us what? Gives us negative 56 into 4 minus 7x to the power of 3. And there you go. That is your answer. Okay, all good now? All right, you're welcome. Okay, so we are going to skip question number 2 and jump straight to question number 3. Reason is that if we do question 3, through question 3, we can cover the concept of question 2 as well. Okay, so I'll solve a couple of questions from question 3 for you guys, and then I'll give you some questions to solve. So I'll do part C. Pay close attention. So first thing you want to do in part C is write it nicely. You have 2x squared minus 1 inside the square root, which means 2x squared minus 1 to the power half. Okay, now we're going to differentiate it. So dy by dx, remember first we differentiate the power, half into 2x squared minus 1, okay, to the power of half minus 1, multiplied by the differential of the bracket. And what do we have inside the bracket? We have 2x squared minus 1, which if you differentiate, you get 4x. Okay, now there is some simplification that we need to do. 2 1s are, 2 2s are. So dy by dx becomes 2x into 2x squared minus 1 to the power minus half. Or if you want, you can keep the power, you can make the power positive, and when you do that, 2x squared minus 1 to the power positive half might as well write it as square root of 2x squared minus 1. Okay, but this is up to you. Remember, if you leave your answer like this, or if you write your answer like this, you're not going to get any extra marks for writing your answer like this, and you're not going to lose any marks for leaving your answer like this. Okay, so it's entirely up to you how you leave your answer. Okay, so I'll do one more part, then I'll give you some questions to solve. I would like to do part G. So what's the first thing? Yeah, part G. What's the first thing you guys suggest that I should do in part G?
1 upon 2x minus 5 to the power half.
ठीक है, चलो. You've added an additional layer of working. No harm in doing that. Then what? Can I differentiate it now? No, I can't. It's in the denominator. Yes, moment. So now what I can do is, because all the rules that we know work when the expression is in the numerator. So if it's not in the numerator, no big deal. We can always bring it in the numerator by using rules of indices, okay? Now I can differentiate it. So at this stage is what I like to call it differentiation ready. Why? Because it's ready to be differentiated. Now if you differentiate it, this is what you get. Dy by dx is equals to minus half into 2x minus 5 to the power minus half minus 1. Don't do this directly. See, when we're subtracting integers, that's something that you can do directly. So, but when we're subtracting fractions and integers, I don't prefer to write the answer directly. I prefer to add an additional layer of working and then write the end result in the following step. Okay, like for example, over here, 4 minus 1 is 3. I've written it directly. I didn't show that step where I'm doing 4 minus 1. Here's 8 minus 1 is 7. I didn't show that step because it's very simple. Here, I'm showing this step because I don't want to lose any marks for making a calculation error, okay? And then multiplied by the differential of 2x minus 5, which is just 2. Now do some simplification. The 2's get cancelled out. And now we have minus 1 over, in fact, let's not skip a step, 2x minus 5 to the power, if you can't work out minus half minus 1 mentally, nothing to worry about, nothing to be ashamed of, use your calculator. Although it's minus 3 upon 2, in case you're wondering. So you can leave it like this, or if you want, you can write it like this: minus 1 over 2x minus 5 to the power 3 upon 2. And you know what? What's even interesting is that you can also write it like this: minus 1 over 2x minus 5, the whole thing cubed, inside the square root. Can I write it like this? Chalo, let's put it that way. Can we write to the power 3 upon 2 like this? Yes or no? Y as in Y, or Y as in short for yes? Fawaz? Yes, we can. Okay. Power 3 means that you're cubing it, and upon 2 means that you're taking the square root. Okay, so you can write it like this. The reason why I'm telling you guys this is because this is what you may get as your final answer, and at the back you might see it written like this. But whenever a question says something, whenever the question gives you an answer which can be written in multiple forms, it will always say or equivalent, which means that you can write it the way it's given in the marking scheme, or you can write something that's equal to that. Okay? So, any questions? If yes, feel free to ask. Yeah, OE means or equivalent. That's what OE means. Okay? Acha. So I will give you guys some questions to solve. Don't rush into these questions, please. Take your time. No extra marks for getting them, for being the first one to solve them. I'd like you guys to do part D, part F. No, wait a minute. Don't do part F. Part E and H. D, E, H. Solve these. I'll give you plenty of time. I'll give you 5 minutes for these questions because I don't want you to rush into them. I want you to get them right. Doesn't matter how long it takes you. So, answer to part D. This is what it looks like. 3x square minus 5, okay, over 2 into square root of x cube minus 5x. Okay, this is what the final answer looks like. Now, what does that mean? Does that mean that your answer should be exactly the same? Nope, not at all. So you might have written it like this: 1 over 2 into x cube minus 5x to the power negative half into 3x square minus 5. That is also perfectly all right. Nothing to worry about. Okay? So don't think that if you don't write it like this, you lose marks or something. Aisa kuch nahi hai. This is what it looks like. Just make sure you read the question carefully. Unless the question has a specific condition, then you got to make sure you fulfill that condition.
Sir,
Yeah.
would this be correct if I multiply, if I write it like 3x square minus 5 upon 2? And then
Yeah.
write the. Okay.
See, it's multiplication, right? So changing the order won't make a difference. Like, for example, even if you write 1 upon 2 at the very end, that's perfectly all right. Or even if you write upon 2 with, let's say, 3x squared up minus 5, or maybe you write upon 2 with x cubed minus 5x, that's perfectly all right. Ultimately, it's multiplication, okay? So order doesn't matter. All right, then you have, what's the other part that I gave you guys to solve? Part E. No. Yeah, so here is what the answer to part E looks like. It's minus 2 over 3 square root of, no, wait a minute, cube root of 5 minus 2x, the whole thing square. Okay, this is what it is at the back. Now, if your answer looks like this, if your answer looks like minus 2 upon 3 into, no, wait a minute, minus 2 upon 3 into 5 minus 2x to the power negative 2 upon 3, that's also perfectly all right. Nothing to worry about. Yeah, nothing to worry about. Okay. Yes, I can do part D. Now, I don't mind solving these questions, but you should be able to get these questions right. Okay, I have no issues solving the questions you guys want me to solve, but if you're not getting these questions right, it's not a good sign. Okay, see what you're.
Sir, I'm
Yeah, yeah.
getting negative on 3 for part E.
Negative 2 upon 3.
Negative 4. Negative 4 upon 3.
Okay, I'll solve it. I'll solve part E as well. Okay. Okay, so dy by dx. In fact, let's skip a step. One small step, not a big step, and write this as x cubed minus 5x to the power half right away. Okay, you got positive 2 upon 3. Okay, hold on. So dy by dx is now going to be equal to 1 upon 2 x cubed minus 5x to the power half minus 1 multiplied by the differential of the bracket, which means 3x square minus 5. Okay, then you can write it nicely, 3x square minus 5 in the numerator, and half minus 1 becomes negative half. If you shift this in the denominator, it's going to be x cubed minus 5x, either to the power negative half or either to the power half or inside the square root. And don't forget that you have a 1 upon 2 as well. Okay? So I hope it's clear now. I don't know who asked. Inshallah. Inshallah, I hope it's clear now. Acha, I'll do part E now. Here's part E. 5 minus 2x to the power. What's the power? The power is 2 upon 3. Okay, this is what the power is going to be. Sorry, not 2 upon 3. Wait a minute. It's going to be 1 upon 3. Yeah, it's going to be 1 upon 3. Because you're taking the cube root, right? Yeah, so it's going to be 1 upon 3. Okay, now if you differentiate it, let's see what do we get. 1 upon 3 multiplied by 5 minus 2x to the power 1 upon 3 minus 1. So if you want to write it directly, I don't recommend that. Let's write it as 1 upon 3 minus 1 only. And then multiplied by the differential of the bracket, which is going to be negative 2. So minus 2 upon 3 multiplied by 5 minus 2x to the power minus 2 upon 3. Okay, this is also perfectly all right. Then you can shift it in the denominator if you want to make the power positive. Okay. Then the other question that I gave you guys to solve was part H. And I think you guys want me to do part H as well. Chalo, I'll do it. So first let's write it nicely. 6 into, you're welcome, 2 minus 3x to the power negative 1 upon 3. Okay, because you're taking the cube root in the denominator. If you shift it into the numerator, it's going to be negative 1 upon 3. Now let's differentiate it. So 6 when you multiply it by negative 1 upon 3 becomes, well, you can write it directly, minus 2. ठीक है, इतना तो कर सकते हैं. 2 minus 3x to the power negative 1 upon 3 negative 1 multiplied by the differential of the bracket, which is minus 3. All right. Then minus 2 into minus 3 becomes positive 6 into 2 minus 3x to the power minus 4 upon 3. Okay. Or 6 over 2 minus 3x to the power 4 upon 3. That is also perfectly all right. Okay. So there you go. That's your answer. Now, see, as far as just the differentiation part is concerned, honestly, if you think about it, there's not a lot of thinking that you have to do. You don't really have to sit down and think, what equation should you make and how should you solve it, or what equation should you solve it simultaneously with. It's just a simple rule, 2 rules actually, that you have to remember. So you got to make sure that you practice. I'll give you guys some questions as homework. You got to make sure that you practice so that you get a good grip on it. And the only way to get a good grip on it is by practicing. Okay, there is no other miraculous way of getting a good grip on this, and you need a good grip on this. All right? You got to make sure that you practice this enough so that you have a good grip on it. Answer to part F. Okay, answer to part F is 3 over square root of 3x plus 1. I don't think I gave you guys part F to solve, but if you've done it, I'll write it down. The power is minus 4 upon 3. If you keep it in the numerator, if you shift it in the denominator, it's positive 4 upon 3. So the answer to part F, moment, is 3 over square root of 3x plus 1. Okay. Okay, now we have some word problems related to this concept. We are I did give you guys part F. Acha. No, I didn't. Acha, I did. Okay. Yeah. So here's the answer. Answer to part F is 3 over square root of 3x plus 1. Okay, part F, I hope you guys have solved without my help. If you haven't, I would still encourage you guys to do it yourself without my help. So we're going to do some word problems. Not all. We're only going to do some of them. And then I'd like you guys to do some yourself later on. Here they are. Let's see. Find the gradient of the curve at the point 2, 1. So, can you guys tell me in 2 sentences what we're going to do? Or in 1 sentence? I'm not looking for the final answer. I'm looking for what we need. Differentiate, step 1, and then? Plug in 2. That's it. Okay. So, go ahead. I'd like you guys to try it. Try out question number 4 and try question number 5. In fact, don't do 5. You know what? Do question number 6. Do 4 and 6. Since you guys already know how to differentiate, the only thing new here for you guys will be the plugging in part. And remember one thing. When you have to plug in a value of x, there's no point in simplifying. Okay, there's no point in simplifying dy by dx because ultimately we have to plug in a value and get an answer at the end. Okay, so go ahead. I'll give you guys 3 minutes for these 2 questions. And let me know when you're done. The answer to question number 4 is 4. Sorry, it's 10. It's 10. Answer to question number 4 is 10. Okay, see if you guys can give me the answer to question number 6.
In question number 6, first we will form a quadratic equation, right? To get the x points.
Yeah. Make sure you read the question carefully. It says find the gradient of the curve at the points where the curve crosses the x-axis. Points ka matlab that you are likely to get 2 values of x. And where do you have to find out the gradients? You have to find out the gradients where the curve crosses the x-axis. That means in order to find out the x values, you're going to plug in y as 0 in the original equation, of course, because that's where you find y. And then find the values of x, which you are then going to plug in dy by dx. Such I just realized I think I gave you guys not enough time. I didn't realize the complexity of the question, but I'll give you guys 3 minutes starting now, just for question 6. And for those of you who didn't get the correct answer for question number 4, see what you've done wrong. I'm not going to solve it. I want you guys to see what you've done wrong. Make a mental note of it. Okay. All right. So looks like we have an answer. 4 over 3 and 0. While 4 over 3 is correct, the other answer is 4. When x equals to 1, dy by dx is equals to 4 upon 3. Good job. When x equals to minus 3, dy by dx is equals to 4. Okay, so here's how we're going to do it. Pay close attention. This is the equation of the curve. All right. Now, I would like you guys to sort of visualize what we're doing. Okay? This is not something, obviously, you're going to do in the exam, but this will help you understand what we're doing really. Okay? So, this is what we have. Y equals to x minus, let's make a fraction, 3 over x plus 2. Okay, this is what we have. So, this is the curve. This is what the curve looks like. Wait a minute. It's not what I had in mind. Yeah. And you can see that this curve is crossing the x-axis. Okay. This curve is crossing the x-axis at 2 values of x. One is 1 and the other is minus 3. Okay. Now, what you're asked to do is find out the gradient of the curve. Now, what do we mean when we say gradient of the curve? We don't actually mean the gradient of the curve. We actually mean that the gradient of the tangent to the curve. So, imagine that at this point, you have a tangent line. Okay, not accurately drawn, so please excuse me for that. In fact, let me try and do it one more time. Oops. and something like this. So, you know what you're supposed to do is you're supposed to find out the gradient of these lines that I've drawn here. Okay, this is what we're doing. This is what we're doing in the background. Now, before I can find out dy by dx is dependent on what? Dy by dx is always dependent on x, because when you differentiate something that's in terms of x, you get dy by dx, which is also in terms of x. So, what we need to do is we need to find out those x values. And the way to do that is through this information where the curve crosses the y-axis, okay? So 0 is equals to, the correct answers, I'll write them down. The correct answers are 0, oh sorry, not 0, 4 and 4 upon 3, okay? So if you've gotten 4 comma 4 upon 3, then you can celebrate because those are the correct answers. What's wrong?
Yeah, I did get 4 upon 3, but I'm not sure how we are getting the second answer as 4.
Tero. Yeah. So I'll write it down over here. 4 comma 4 upon 3. These are the correct answers. Okay, now let's see how. So curve crosses the x-axis. That means y is equals to 0. So 0 is equals to 3 over x plus 2. All right. Let's move 3 over x plus 2 over to the other side. So this is what we're looking at. Let's cross multiply. So we have x square plus 2x minus 3 equals to 0. Okay, I've skipped a step. When you solve this, the two values of x that you get are 1, and the other value that you get is minus 3. Okay. Now, what are we going to do with these values? Are we going to plug them back into the equation? Are we going to plug them back into the equation of the curve? Yes or no? What do you think will happen if I plug them back into the equation of the curve? Think about it. It will give 0. Why? Because we've equated the equation to 0 and we've gotten these values of x. If we plug in these values of x back into the equation, we'll get y as 0. Okay? So, this is what the equation looks like once you write it nicely. Okay? Once you make a differentiation ready. Now, when you differentiate it, this is what you get. You get 1 minus 3 into minus 1 will give you positive 3. X plus 2 to the power of minus 2. Okay? And then if you want, you can just write it like this. 1 over 3 over x plus 2, the whole thing square. This is what you get as dy by dx. Okay? Now, let's shoot two arrows from here. Plug in the values of x one by one. Let's plug in 1 and let's plug in negative 3. Okay, I'll skip a few steps here. If you plug in 1, 1 plus 2 is 3. 3 square is 9. 3 upon 9 is 1 upon 3. 1 plus 1 upon 3 is 4 upon 3. And then if you plug in minus 3, minus 3 plus 2 is negative 1. Negative 1 squared is 1. 3 upon 1 is 3. 3 plus 1 is 4. dy by dx equals to 4. That's how this works. Okay? So those of you who are not getting the correct answer, I'm pretty sure you have made an error while differentiating. Maybe a sign error, or maybe you didn't write the power correctly. Nothing major, but something like this. So how come the x will be 1? What happens when you differentiate x? What's the power on x? It's 1. So 1 gets multiplied, you take 1 away from the power, so it just becomes 1. Okay? All right, now, I would like you guys to, won't it be minus 1? What will be minus 1, Hassan? Minus 1 plus 3. In front of the bracket. Kidhar, kidhar? In dy by dx, minus 1 plus 3. I'm not sure I understand what you're saying. When you multiply minus 1, you've made 3 positive. Okay, so minus 1 into minus 3 will make it positive. But 1 remained positive and did not change. Okay, let me
I guess maybe the brother is confused. He's saying that minus 1 will be multiplied with the one that came from x.
Wait, let me read it again. So when you multiply minus 1, you made 3 positive, but 1 remained positive and did not change. Okay. So I'll walk you through the steps one more time because I'm not sure I understand what you're trying to say. So minus 1. All right, let's suppose. Let me add an additional layer of working over here. That should help. Here's the thing. dy by dx equals to 1. Okay, this part is clear, right? When you differentiate x, you get 1. I hope that part is clear. Let's say we let the minus be as it is. Okay, let's say we keep it as 3 only. And then when we multiply minus 1 by 3, we get minus 3. Okay. And then x plus 2 to the power minus 1, which is how we get minus 2. And then what do we multiply it with? We multiply it by the differential of the bracket, x plus 2, which is 1. And now, if you look at this step, I think it will make more sense. Yes. This one is multiplied by only positive 3 and not by anything else. Because this is the composite function, okay? So the general rule is applied to this function only. Okay, does that help? All right, brilliant. Okay, now we have around 30 minutes, which is enough time for us to learn another important concept, and that is called equation of tangent slash normal. Okay, equation of tangent slash normal. Now you can expect a good 4 or 5 mark question on this topic, on this concept. Okay, depending on the kind of function that you're dealing with, it can be even more than that. Is there something called, oh yeah, I forgot to stop the timer. Yeah, there is something called volume by rotation that comes in integration. Okay, that is probably going to be the last concept of integration. It's not that difficult. No, not in differentiation. That is something that comes in integration, volume by rotation. No, it's not that difficult. It's not. Okay, so equation of tangent and equation of normal. Let's talk about this. You guys know what a tangent is? And do you guys know what a normal is? Have we discussed normal? I don't think we've come across normal before. Have we discussed this term? Okay, if you know it already, that's a different story, but have we discussed it or not? I don't think we have. Okay. Normal is basically a perpendicular line. Okay, normal in math means a line that is perpendicular. Okay, so here's a curve, a quadratic curve, and let's say that we are supposed to find out the equation of tangent. Let's start with tangent at a particular value of x. Okay, and let's call this value of x x1. Okay, let's say we're supposed to find out the equation of tangent of this curve y equals to f of x at x equals to x1. Okay, that's what the question is. Find the equation of tangent to the curve y is equals to f of x at x equals to x1. Okay. Now, when we say tangent, what is tangent? Tangent is nothing but a straight line. Okay, this is what the tangent line looks like. Okay, and normal, although we'll look into it in detail, but what the line that I've drawn in green is the normal line. Okay, and they're both making a 90-degree angle. So I'll write down over here, the red line is the tangent line because it's tangent to the curve. The normal line, the green line, is the normal line. Why? Because it's perpendicular to the curve. Okay. Now, at the moment, we're only focusing on the equation of tangent. Equation of normal we'll look into later on once we're done with tangent. Okay. So, if you think about it, in order to find out the equation of a straight line, Yes, normal is just perpendicular to tangent. Okay, normal line is nothing but a line that's perpendicular to the tangent. Okay, now if you think about it, if we talk about the equation of a straight line, what do we need in order to find out the equation of a straight line? Let's just take a few steps back. Let's go back to coordinate geometry. If you're asked to find out the equation of a straight line, what do you need? You need one coordinate? No, you don't need one coordinate, you need one point. Okay, you need a gradient and a point. That's it. You need the gradient and a point. Okay, x, y together, x, y coordinates together make up one point. Okay, so in order to find out the equation of any straight line, you need two things. You need the gradient and you need a point. And when we say point, we mean x as well as y. So x1, y1. Okay. Now these are the boxes that we have to check. And if we can check these boxes, if we have these two ingredients, that means we have enough information to find out the equation of a straight line. All right, keep that in mind. Now, any idea how we can find out the gradient of tangent? We've done questions like these. But what do you guys think? If I want to find out the gradient of this tangent, what do you suggest I do? What should be my first step? Considering that I know the equation of the curve and considering I know the x coordinate, what do you think? Differentiate, okay, then and input x. That's correct. Okay, if you look at all the questions that we have done so far, find the gradient of the curve at the point. So how did you do that? You differentiated the equation of the curve, plugged in the value of x. Find the gradient of the curve at the point. Okay, we didn't do this question, but yeah. Find the gradient of the curve y equals to x minus x1 at the point so and so. We differentiated, we plugged in the values of x, and what did we get? There's a reason why I showed you guys an illustration of this question. What did we get? We got the gradient of the tangents. Okay, we didn't get the equation of tangent. That's not what we were supposed to do earlier. We got the gradient of tangent. You can see one is 4 upon 3. This is probably 4 upon 3. Or maybe the other way around. That's not relevant. But yeah, that's what we got. Once we differentiate and plug in the value of x, you get the gradient of the tangent line at that value of x. Okay, so that means we know what the first step is going to be. The first step is going to be to find dy by dx or f prime of x. Okay, how do you do that? By differentiating the equation of the curve. Long story short, just differentiate the equation of the curve. Okay, so find dy by dx by differentiating the equation of the curve. Okay, so that's step one. What should be step two? Step two should be to plug in x equals to x1 in dy by dx. Okay, what happens when you plug in x equals to x1 in dy by dx? What do you get? You get the gradient of tangent. Okay, to find gradient of tangent. So what have we done? We have checked the gradient box. Okay, now what's missing? We have the x coordinate, we have the gradient, but we don't have the y coordinate. What do I do? Achha, by the way, keep in mind that the gradient of tangent is what we are now going to refer to as mt. M for gradient, t for tangent. Put in x equals to 0. That's interesting. Why 0? Why 0? Yes, Ahmad, what you're saying is correct. We are going to plug in. See, what do we want? We want the corresponding y coordinate. Okay, what do we want? We want the corresponding y coordinate. We want to know what y is equal to when x is equals to x1. So technically we want y1. So what should I do to get y1? I should plug in x equals to x1, but this time I'm not going to plug in dy by dx. We've already done that. We're going to plug it in the equation of the curve. It's like you have a curve, you know x coordinate of a certain point, and you need to find out the y coordinate. What do you do for that? You plug in the x coordinate. So then comes step number 3. That is, you plug in x equals x1 in equation of the curve to find y1. After step 3, you've checked the point box as well. Now, once you've checked both the boxes, then comes step 4, the fourth and the final step, that is form an equation. Form an equation using y minus y1 equals to mt, that is the gradient of tangent, x minus x1. And that's it. That is your answer. Okay. So if we have the gradient of the red line, what should we do in order to find out the gradient of the green line, the normal line? What do you think? Considering that they're both perpendicular. Negative reciprocal. Okay. So if you think about it, the point is common. Okay. They're both tangent and normal at the same value of x. That means the x and y coordinates are the same for both the lines. The only thing different is the gradient. So what are we going to do if we have to find out the equation of tangent? We're going to do y minus y1 equals to minus 1 upon mt into x minus x1. And this will give us what? This will give us the equation of normal. And why is that? Let's think about it. That's because the gradient of the normal is going to be the negative reciprocal of the gradient of tangent. And why is that? That's because they're both perpendicular. Okay. So this is what it looks like. Now, take a good look at it. Let me know if you have any questions. Okay. We can use, okay, I've, what is that? What is that for us? Oh. Okay.
There's a teacher whose channel name is Quick Results, so he had a club. We got a new time for the AS classes, so they are clashing in on the Tuesday. So I was just talking about that.
Okay. All right, so I have a question for which I'm going to solve as an example. It's a very simple question. Here it is. Find the equation of tangent and normal to the curve, so and so, at the point where x is equals to 2. Okay. Now, you don't necessarily have to do everything in the same order. Like, for example, if you want, you can find out the y coordinate first and then find the gradient, because ultimately you will need the y coordinate. But of course, you will form the equation at the very end. Okay. So let's solve this example, and it's going to help us cement our understanding of this concept. So first thing we need to do is we can differentiate it. Okay, that's the first thing we can do. Although we can always plug in the x coordinate, find the corresponding y coordinate as well. But before I differentiate, if that's what we decide to do, we need to first make sure that we write it nicely. Okay. Now can we differentiate it? Yes, we can very easily. 2x squared, what happens when you differentiate it? You get 4x. Minus 2 into 8 will give you negative 16, x to the power minus 3. And minus 9, what happens when you differentiate it? You get 0, so might as well not write it at all. So what do we get? We get dy by dx to be equal to 4x minus 16 over x cubed. All right. Now let's plug in 2. So dy by dx when x equals to 2. Okay, let's see what we get. So dy by dx equals to 4 into 2 minus 16 into 2 cubed. Okay, so what's 4 into 2? That's 8. What's 2 cubed? That's also 8. 16 upon 8 is 2. So that means dy by dx is equals to 8 minus 2, which is 6, which means the gradient of tangent is equal to 6. Now, if the gradient of tangent is 6, what will be the gradient of normal? Minus 1 upon 6, okay? So you might want to write it over here, minus 1 upon 6. Although we don't need them immediately. We don't need the gradient of normal immediately. We need to first find out the equation of tangent. Okay, so we've done step 1, we've done step 2. Now let's do step 3, which is that we plug in the x coordinate in the equation of the curve to find out the y coordinate. Okay, so that's what I'm doing now. 2 into 2 squared plus 8 upon 2 squared minus 9. Okay, let's see what we get. So I'm just going to use a calculator over here to save some time. 2 into 2 squared plus 8 upon 2 squared minus 9. So we're looking at 1. So here's what we need to do. If we're talking about the equation of tangent, the gradient of tangent is equals to 6. The point through which the tangent line is passing is 2 comma 1. So let's put this information together. Y minus 1 is equals to 6 into x minus 2, which means y minus 1 equals to 6x minus 12, which means y is equals to 6x minus 11. Okay, so that's your equation of tangent. Then let's find out the equation of normal. The gradient of normal is equals to minus 1 upon 6. The point through which the normal is passing is also 2 comma 1. Okay, so let's put this together. Y minus 1 equals to minus 1 upon 6 into x minus 2. Cross multiply 6y minus 6 equals to negative x plus 2. So we have 6y equals to negative x plus 8 as our final answer. And that's it. That's your answer. Take a good look at it. Let me know if you have any questions. KSA is in zone 3 and UAE is in zone 4. That does not make sense. Okay, I don't know how they do the division of the zones, honestly. But I don't think there's a major difference in the timetable. I don't think there's a major difference. At max, maybe AM PM difference. Sir, did I tell you about the new rule in KSA? Yeah, the fact that you have to give the exam through a school only. You can't give it privately. Yeah, I remember. Shouldn't we give the answer in the form y equals to mx plus c? If you want, you can. But the question had no restriction. The question had no specific requirement. So we can leave it however way we want. Okay. So we have around 10 minutes. I would like you guys to do one example so I can make sure you've understood the concept, and then I'll leave you. And then we'll call it a day, basically. Here, a very simple question, not at all complicated. How much of differentiation is left? So we are almost done with basic differentiation. The only differentiation that's left now is further differentiation. Okay, so now that you've asked, we're doing 7C. So after 7C, we have one more exercise, although this is something we can skip because we're going to cover it in further differentiation anyway. But you can say that we are done with. Okay, y equals to 3x minus 7 is the correct answer. Y equals to 3x minus 7 is the correct answer. Yeah, y minus 2 equals to 3x minus 9 is also correct, except that we can't leave it like that. Okay. So let's keep it till here only. In the next class, inshallah, we are going to do some more questions about equation of tangent and equation of normal. Of course, you can't, because this is something that can be further simplified. Okay, the minus 9 and the minus 2, you can further simplify it, so you can't leave it like that. Okay, it's not specified, but see, there is a standard rule. Like, for example, are you ever going to leave your answer like this? X equals to 2 plus 1. Even though it's correct. But you're not going to leave your answer like this, right? Why? Because it can be further simplified. So for the same reason, you can't leave your answer as y minus 2 equals to 3x minus 9, because the minus 2 and the minus 9 can be further simplified. This goes without saying. Okay. All right. So I'll stop here. We have learned two things today. One, how to differentiate composite functions, or functions that have a whole power. And the other is finding the equation of tangent and normal. So we're not done with equation of tangent and normal. We're done with the main concept. We are going to do some difficult questions. Okay, you have some questions. We have to find the area and everything. So we're gonna do that, inshallah, in the next class, and hopefully in the next class also we can start the next exercise of differentiation. Yes, definitely, definitely, you guys will have homework as well. So once the session is over, so you guys will have access to the recordings, inshallah, till the end of the year. So anyone who decides to give in October, November, God forbid, let's say they don't get a good result and they decide to give a retake, you will have access to the recordings. Okay? So I will stop here. See you guys, inshallah, on Thursday. So take care, everyone. Allah Hafiz.